Okay, 14.22 is our next problem, and it says in February of 2004, scientists at Purdue University used a highly sensitive technique to measure the mass of a vaccine virus. The procedure involved measuring the frequency of oscillation of a tiny sliver of silicon with a laser. First without the virus, and then after the virus had attached itself to the silicon. The difference in mass caused by the change in frequency. We can model such a process as a mass on a spring. Whew. Okay, so the first part of this problem is to show that the ratio of the frequency of the mass plus of the virus plus the silicon over the frequency of silicon is equal to the square root of mass of silicon over mass of the virus plus mass of silicon. So to do that, it's kind of a pain in the butt, but it's not too difficult, so let's just dive right into it. First, we know that the frequency of, just in general, is given by 1 over 2 pi times the spring constant over its mass. So now, what we want to do is just kind of define the frequencies for our different variables here. So we have the frequency of our virus plus silicon is going to be 1 over 2 pi times the square root of our spring constant, mass of virus plus mass of silicon. And then our frequency for just the silicon is equal to 1 over 2 pi times the square root of our spring constant over just the mass of silicon. So now to find the ratio between those, we simply just divide them out. So that is going to be B plus S Okay, so right off the bat here, we can see that our outside terms will cancel out, and then inside the radical here, our spring constants will also cancel out since they are the same value. So we rewrite that as so we rewrite that as radical 1 divided by the mass of the virus plus the mass of the silicon over radical 1 over mass of silicon. And these fractions allow us to basically just swap places here. So that's going to be the root mass of silicon over root mass of virus plus mass of silicon. And then, just as a rule of algebra, we don't want a radical in the denominator. Actually, let's just ignore that. It'll be easier if we just leave it as is. We could go on and do a bunch more steps to radicalize this out and all that other stuff, but it turns out that it's a lot easier just keeping it as is. So that's part A. I'm going to do part B in the next video.